So my name is Joe Binder. I'm a program manager at Microsoft on the Visual Basic team. And I'm going to be talking about the My Namespace today. And specifically, we're really going to be taking a really deep look at how the My Namespace is implemented, how you can extend it, and how you can customize certain elements within it. So I'd really like to thank you all for coming. This is a new talk for us. We've never given it before, and it's something that I'm pretty excited to give because it's an area of the product that I think really deserves a lot more limelight that it gets. So a few things that I'd really like to have you guys walk away with is a real deep understanding of some of what we call the My magic. You know, how many people, just out of curiosity, have used My or are somewhat familiar with it? Okay, so a pretty good percentage of the audience. That's good. So we're really not going to spend much time at all at sort of the surface level of My. We're going to be spending most of the time understanding how this magic under the hood really works, with the interest of giving you guys the tools and the knowledge that you need to sort of tweak its behavior and get My to do exactly what you're looking for. Within My, there are several areas that work out of the box, that work great. You've probably used them. And yet, we've exposed several extensibility points that you can use to customize. So oftentimes what happens is things work great for the 80% scenario, and there's this 20% scenario where you would like it to do something just a little bit different. And we'll be spending the bulk of the time in demos looking at those individual customization points. Lastly, I know a lot of people are here for the My extensibility portion, and that's really included throughout the demo. This point specifically is what's going to enable you to add your own things to the My Namespace. If you're a control vendor, maybe you have something that you use a lot and you're really excited about the simplified user experience that My provides and you want to add something to that. The extensibility model is really your plug into the My Namespace. And I've sort of framed the talk based solely on questions that have come up. You know, we see a lot of recurring themes with any new product, and My is no different. You know, on the forums, people always ask, what exactly is My.settings, and can I just edit the config file, and why does My.form show up in one class library and not in another, and what's the deal here? So we're really going to be tackling a lot of these common questions throughout the demo, and probably have a good 15 minutes after the demos are complete to address your individual questions that I may not have gotten to. And certainly, I have to admit that I have a bit of a cold, and I've probably taken more than the recommended dosage of Robitussin prior to the talk. So if I start to ramble off in sort of a stupor or you want to see something else, just kind of tag it, and we'll save it to the end, and I'll be happy to go back and clarify or give you an ad hoc demo of something that maybe wasn't shown. So as we look at the My Namespace, if you were at the PDC in 2003, you probably saw this exact same slide. And we kind of talked about all the cool things that were in there. Well, what I'm going to talk about is more what's in here and what you can add to this picture. So we start with My.application. In my mind, My.application is really the guts of My. It's what controls your application's behavior. It fires events. It enables you to do things like single instancing. And we've exposed a number of properties and methods that you can override to make My.application do exactly what you want. I'll also be spending a fair amount of time with My.application.log, just because that's a feature that seems to show up a lot in applications. We get a lot of questions on it, and I've written a few extensions to that I think you'll find pretty interesting. My.computer sort of follows the same extensibility model as My.application. You can add properties and methods to that. I'll probably add some hardware events and things like that at the end. And this is just a great place to extend, I think, because a lot of people find that they have specific hardware APIs that they like to call that would be best suited to fit within My. My.user, as you know, the demo we always like to give is we show the code that it takes to wire up the Windows credentials to My.user using just the framework, and then we just show you My.user.name, and it just works, and it's so cool. Well, it is so cool, but the problem is that sometimes there are other authorization and authentication mechanisms that you need to use. So we're going to use a SQL role provider and use that instead of Windows authentication. My.settings, probably my pet feature, if I can say so. When we think of settings, we think of config files in the .NET world. But my.settings was really designed as a higher level abstraction of settings. And we're going to take the concept of my.settings, build a little WinForms app, personalize it a bit, and then actually use the registry instead of config files to store all those settings. And lastly, we'll spend some time at the end just looking at where, how, and when you can actually add new properties to the top level of My. And really spend a fair amount of time at the end of the talk discussing some of the design guidelines, some of the pitfalls with extending My, etc. Before we sort of dive into the individual pieces of My, though, I really want to take a few seconds to at least discuss the sort of big picture. And one of the biggest questions, and frankly complaints that we get is, you know, I type my dot in my project, everything works, and I look in Microsoft Visual Basic because I know it's a VB feature, and I can't find it. How does this namespace actually get into my project, and what am I actually using when I type my dot? And this slide gives sort of a sketch of how this works. The secret is that every time you compile a Visual Basic project in 2005, the compiler is actually emitting a source file that you don't see. The source file is the one that's in red at the top. And this contains the My namespace definition itself, along with all the properties that are exposed in there. So if we were to crack open this file, it's unfortunately in memory. It's not on disk, so I can't even show you in the demo. You would see an actual property definition, my.application. It'd be a namespace My, a module, and an individual property called application. The same holds true for computer. For forms and web services, we do some additional compiler magic under the hood, etc. But the main thing that I want everybody to take away from this slide is just that if you want to control what's in the My namespace, if you want to alter anything, any My namespace member's behavior, you need to do it in the current project. Now, not everything, however, is obviously in the project. Otherwise, the project of typical Visual Basic project would be very large. So what we do is we provide this sort of conduit to get from the project to Microsoft Visual Basic in a bunch of system DLLs that contain these commonly used types. So what happens is if we were to actually look at this template file, this in-memory file that the compiler emits, we would see that there's a namespace My, a property called application, and that property is returning a type that is also defined within the project. This type is basically a derivative of the application object that's defined in Microsoft Visual Basic. This derivative is declared partial. That's why we can add things to it. And this is the basic paradigm that we follow throughout My. I don't expect anybody to actually understand how this is working right now. We're going to spend quite a lot of time actually looking at the code and adding some stuff ourselves. But I just want to give you an overview of kind of the big pieces. And the main takeaway is just that the My namespace is in your project. And if you want to add anything to the My namespace, you have to do it within your project. It can't be in a separate class library. So as a VB user, you know, moving from a bunch of different languages, I have sort of an interest in just sort of learning all sorts of languages. One of the things I was most impressed with the first time I used VB was I created a new project, and I hit F5, and a form came up. I didn't write any code. I had no idea how it got there, but I was pretty impressed that the form just sort of showed up. So that's great. And for most things where you can do some logic in the form load, for example, this paradigm works really well. But the problem that we heard is that oftentimes there's some logic that you need to interject before the form's loaded. The simple answer is to use a submain, right? Well, if you use a submain, then you have to do all the heavy lifting. If you want to use things like this single instancing, maybe you want to handle some application events, you have to wire up all that logic yourself. It's all or nothing. So when we designed 2005, we really sought to provide extensibility hooks into this application flow. So it's not all or nothing anymore. Basically, you can have a main form that just shows, that just works, or you can provide several different workflow sort of conditional paths without actually having to author a submain and deal with all the threading issues and things like that that often go with it. So before jumping into code, I just want to give you a brief overview of how this works. So if we look at the top box here, this is a submain that's actually defined within that template that I showed on the previous slide. It's in part of a source file that you don't see, but it's compiled with your project. This is where it all begins. What happens is just one line of code in this method, just calls my.application.run. The next piece is still within your project, and this is what enables you to extend my to alter the application behavior, maybe how it starts up. So we call run on this partial class, which is defined in your project. You could then say, stop the application from running. We're going to override some methods in this step. And then it goes to the logic that's actually written in Microsoft at visualbasic.dll. So, and that's where all the events themselves are actually fired. So I don't want to spend a lot of time in slides. I'm not really much of a slide person. We're going to spend the rest of the time just looking at demos. And I am very much an API person. I never design UI. This would be a case study in why. And I really don't want to focus too much on what this application's doing. It's just a simple two-tier app that views a bunch of customers. Okay, if we look on the side here, there's just a simple data layer, just returns a bunch of tables, and then we're displaying those within the main form. Now, I've written this app in Everett, actually, and migrated it forward. And part of the logic, I just want to sort of walk through kind of the process of refactoring what you used to have to write in submain using the application model. So here's my submain. Right, the same old stuff. If I run the app, I want my little splash screen thing to come up. I've got some painting issues, obviously. And then I want to show the main form. Real simple. You'll also notice that at the bottom here, I've got this little tool strip thing going on so I can detect when the network availability has changed. So I need to listen to the idle event in order to do that, unfortunately. OK, so let's walk through the code a bit and figure out what's going on. The first thing is I need to show my splash screen. Well, every time somebody asks you to write an application, they always want the splash screen to show for at least a few seconds so the marketing folks can sort of get their glory, right? Well, what I had to do here was just write a real simple thread that if we go to the actual definition of it, it's just in a loop. It's really brain dead. It's just elapsing a certain percentage of time and then returning. So we start off this little thread, then we show the splash screen, and we do some startup work. In this case, I need to do certain things before the main form is shown. The first thing I need to do is, this splash screen's up, and we should actually do some work in the background since we have this, free time, effectively. So what I'm doing here is going out and querying the network status, seeing if we're connected, and then updating this status strip on the bottom while the splash screen's shown. The next thing I do is just hook the idle event so that I can listen for changes. Basically, anytime the application goes idle, I'm going to go see if the network's still connected. Now, the interesting thing about this methodology is that how many people have ever tried to handle or write some asynchronous stuff with Windows Forms and update a UI, right? It's really, really difficult because you always get this cross-thread execution thing, exception, really confusing. Right? You always have to marshal back any requests or any messages back to the UI thread in order to update the UI. That's why I'm handling the idle event here, because the idle event happens to be marshaled back. It's really not the event I want to handle. It's just easier than handling the IP address changed event. So we're going to take a look at why this step isn't going to be necessary in mine in a second. So after we do our startup work here, we're just waiting for the splash screen to finish. It's unfortunate that we have to write this code, but it's pretty straightforward, I guess. So once that's done, we just close the splash screen and run the application. And then from here on out, the application's up and running, and your submain is basically out of the picture. You could always handle the Windows Forms exit event, etc. Now, in addition to the the sort of specific problem that I mentioned with the events and being able to marshal messages back to the UI thread, this technique really there's something very wrong with this in my mind. And that is that every single application I write, almost every single application, has the exact same logic in the beginning, right? It's always, if you always have a splash screen, it's always there. And maybe you write some project template for Visual Studio that always has it in there. But the bottom line is just that you're not reusing any code. You're just writing this monotonous code that you probably figured out once or got from the web, pretty much works, and you use it all the time. What we tried to do with the My Application model is sort of provide you with an opt-in model. Things work out of the box, and if you want to change specific behaviors for a given application, maybe this is the only application that has this network status event, then you can opt in and handle that event individually. You don't have to roll your own submain. So now let's just sort of walk through the process of moving this over to the VB application model. And as we do it, I'm really going to be spending a fair amount of time walking through the individual methods that are fired and where you can control the flow of the application. So the first thing I need to do is turn on the application framework. It says that I can't have a submain. It's telling me twice that I don't need a submain, apparently. I set my main form, and as you can see here, I can turn on a bunch of things. If I want to make this a single instance application, this would be borderline rocket science to do with a submain app. I just click the button here. And now let's go in and actually move all this code over that was in the main module into my application. So the first thing that we need to do is we need to call this update network status method when the application starts up and any time that the network status changes. So go back to application events. And this is pretty simple for us to do. We just handle the startup event. And for the sake of simplicity, I'm just going to move the whole method over here. In the interest of getting rid of that god-awful submain. Okay, so now all I need to do is when my application starts up, I'll update the network status. Okay, and I need to do the same thing anytime that the network availability changes. Now the nice thing about this is that the VB application model automatically marshals back all the events for you. So previously we handled this idle event sort of gratuitously, and we're constantly updating network status even though we didn't have to, just to get the event marshaled back to the UI thread. In My, everything is marshaled back for you. So we can just make the same call here. And that'll take care of sort of the basic logic. Now if we jump back to our main module here, let's say that we actually did want to still handle this idle event. And the interesting thing is that I've actually handled the idle event before the main form is shown. So I'm going to do this before the startup event is fired. Maybe there's some specific logic. Oftentimes the application does go idle before it actually starts, believe it or not. So what I want to actually handle this somewhere before the application starts. So I'll just copy this over here. And if I jump back, you'll see that before the startup event is fired, the VB application model has an uninitialized method. This is effectively the first method that gets called after the submain. So by overriding this method, we can do whatever we want in here. In this case, I'm just going to add a handler for the idle event. System.windowsforms.application. Later in the demo, we're actually going to incorporate and extend my.application to just include this event. But for now, we'll use the other event directly. OK. So now you can see that my scroll bar is going a little crazy here. You can see that we're actually going to handle this event before the startup event is fired. So what I'll do to just sort of illustrate what the overall application flow is, though, is set a bunch of breakpoints here, and you can actually see what gets fired and when. So let's say, for example, I also wanted to perform some logic just before the main form is shown. So maybe my startup logic is to go create a bunch of network connections and go grab some cache data. Well, right before I want to start up the main application, I may want to close those data connections. So the on-run method is exactly what I need to do here. And if I just set a breakpoint, you'll see that it gets fired after the shutdown event, after the startup event, rather. And lastly, there's also the on shutdown. If there's some specific logic that you want to provide before the shutdown event is fired, you can also do that. And we'll set a breakpoint and just run the application. So the first thing you'll see at the top here is that the onInitialize is called. We're now going to add the handler. The startup event has not been started yet. Now the startup event is actually fired. And this is where most developers are probably going to end up adding most of their logic. We'll then go to onRun. This is just before the main form is shown, and then the main form comes up. And once we close it, the shutdown event will be raised. So pretty straightforward stuff. And the main theme here is just that we really try to include the opportunity for you to really control the application control flow at a very granular level. It wasn't enough anymore just to say, well, you either have a submain or you just hit F5 and the form comes up and you're happy, right? So this is particularly interesting. If you wanted to provide your own application object, a great way to do it would be to actually derive from the application object that we're using here and build that derivation into a class library if there's some specific service, let's say, that you wanted to add to all your applications. So we'll get rid of these breakpoints. And while we're in here, I want to just sort of show off one of my favorite events. Those of you who have used the Windows Forms application model probably won't be too excited about it, but I just think it's the greatest thing ever. And the reason why is because I don't know how many applications, and maybe I just have poor taste in applications, but how many applications I see where there's the big red .NET Framework dialog that says, an unhandled exception has occurred in this application. We've all probably seen that, right? And I think having an unhandled exception event and handling that intelligently is a great mitigation for it. Even if it's just a message box that says, hey, we're really sorry, but the application just crashed. That's still better than what's effectively garbly-goop. You know, it shows like the version number and the strong name key of the assembly. I mean, most users are just mystified by it, right? Another thing that's kind of interesting here in the unhandled exception event, though, is we show the exception that was raised, but we also allow you to restart the application if that's feasible. Now, I should say this with a bit of a disclaimer. What we're going to do is the application object is going to try and put you back in the message loop for the main form, right? There's no guarantee that the operation that you were trying to perform or the user was trying to perform when it crashed isn't going to put you in some weird state. So I would say use this, this overload sort of cautiously. Sometimes it works and sometimes it doesn't. What I'd like to do now, though, is use this event as sort of an entry point into customizing my.application.log. So out of the box, my.application.log just works. There's no abstract factories to call, no config files to modify. It just writes to a file and includes all the information, the thread ID, everything that you need. It's really pretty helpful. It does archiving, rollover. I'm really pretty happy with the way that feature turned out. But the problem is that in some cases such as these, if you have an unhandled exception event, you may want to do something more than simply write it to a file, right? And on the flip side, you may not want to pollute the event log, which is kind of the dumping ground of most of our trace messages, with all these, audit messages. Every time, a button is clicked, you don't want to write a message to the event log. So using the customization model of my.application.log, which is really just an extension of the framework, we can really define which messages will go where at a very granular level. So let's jump out of full screen mode. And if you notice in app config, one of the things that I really dislike about configuration-dependent APIs is that you never know what the XML is supposed to look like, right? You always end up Googling some, how do I configure system.net whatever to use some proxy? Because the XML it's XML, right? It's not really designed to be handwritten. So what we provide is at least a starting point that shows you, as soon as you add an app config or you add a setting, we show you the configuration that myapplication.log is using under the hood. So if you were to go ahead and change any of this, you could change exactly what myapplication.log is doing. And we're going to do that here. So right now we're just we're writing to the file, and we'll change it to write to the event log. And all we have to do is uncomment this section. But what I really want to do is not just write every single message to the event log. I want to write just a subset of them. So I can add a filter to this. I don't know how many people write a lot of config files by hand. Not many. Congratulations. All right. Well, the one thing you may notice is that at least in 2005, I'll do it again for the gratuitous plug. We do actually have pretty decent IntelliSense. This is actually looking at the schema for system diagnostics, and it's finding out which elements are currently valid and giving me the IntelliSense for it. It's extremely handy. So all I need to do is provide an event type filter. This is just telling the trace source, whenever you see an event that's of this type or more severe, log the message. And if it's not, if it's lower in severity, then don't log the message at all. And there are a bunch of different ways to filter. I'm just doing sort of the simple case here. And we'll initialize this to write error messages. And in our unhandled exception event, we'll write the message. And as you can see, sort of the simple overload, we always try and put the simple overloads first. I'm kind of mentioning this in the interest of those who are interested in extending we always try and put the first overload first, which is just the message. In this case, we're going to grab the exception message. But you can also specify exactly what the severity of it is. In this case, I consider it critical because the application's about to crash. And we'll take our chances and see if we can restart it, though. OK, so I've included a few cookies in my application here. If we double click on the delete customers button, we're going to throw an exception just to get the application to crash. Usually I don't have to take such explicit steps to get my applications to crash. So as you can see, the splash screen at least paints a little bit better now. When we click on the button, everything seems to work fine. If we go down and open the control panel, actually close the application. Inside, you're going to see that an event, just the error was actually added to the event log. And it's just saying it could not delete the customer. So prior to 2.0, we had some issues in the framework with mapping the cool little icon with the event type. We finally fixed that. So that's kind of the simple case. But this, for me as a developer, this really isn't enough for me, right? A lot of times, just getting an exception message, having some support person call me and say, yeah, they have this error message that says no reference exception. Well, that's not very helpful, right? So what I'd really like to do is actually create one of those familiar Windows crash dialogues and create a mini dump of my application and tie that into the application model. Now, don't worry, I'm not going to actually make you sit through me writing all the code for that. I've already written it, and I'm just going to add it to my project. So basically, we'll delete this guy. And you'll see that in the references for this new project that I added, I've just added a reference to this DLL that I wrote last night in a Robitussin-induced stupor, which seems to work okay. And what we're going to do here is add a trace listener that calls the Watson dump dialog. Does everyone know the dialog I'm talking about? That's unfortunate that you all know what it looks like, but and the extensibility point that we're using here is really part of the .NET framework, and we're just leveraging it directly in my.application.log. So in this case, all we need to do is inherit from trace listener. And there are really just two methods that we need to call. I'm not even going to bother with write in this case. I'm just going to do the write line. And I'll walk you through what the logic to write a crash dump looks like. And OK, so basically what we have here, and I know there's a lot of code, is we're generating this report. We get the application name. That just allows us, when we open the mini-dump or the cab file, to identify which application actually crashed. And then we're doing something that's kind of neat here that I personally find pretty useful, is that in addition to including the mini-dump, which is just a dump of the application that allows us to debug the crash back on the developer's machine, we're also including the log file. So if I've instrumented my application with a fair amount of granularity, I can actually just look at the log file and figure out exactly what the user was doing prior to getting into this state. Because oftentimes the dump will tell you which stacked variables had which values, et cetera, but it's kind of hard to figure out how they actually got into there. So I'm including the log file here, and then just setting some properties and giving the user a nice message. So now, in the same way that we hooked up the event log, we'll go ahead and hook up the Watson crash. Just need to build it first and add a reference to it. OK. Now, if I jump back to app-config, I'll do the same thing that I did for the event log, except to do it for Watson. We just need to provide an identifier for it. This identifier basically allows you to iterate through the listeners that are being used at runtime, should you need to remove one explicitly from the collection. Set the type. And this is the part that's always kind of tricky with config files. When you specify the type, you have to specify the fully qualified name along with the assembly that it lives in. Watson package dot. Usually once in about 10 times, I actually type that properly the first time. So we'll probably get an exception at runtime. And in this case, I don't really care to invoke the Watson dialog for anything other than critical error messages. OK, so let's try and see if it works. In this case, I'm going to fake it out by adding the critical error message before I actually throw the exception. So if I just make a call in here, and run, let's see if it actually works. So, oh, I forgot to actually add it to the log. So what I also need to do is, this section down here basically defines all the listeners that are available to trace. It's the equivalent of doing trace.writeLine. If I want that to show up within my.application.log, I have to add it explicitly. Now, if I hit delete, cannot delete the customer, and usually the crash dump takes about 30 seconds to create, especially for managed code apps. So it will actually come up eventually. Let's just check here. That looks fine. And I'll run outside the debugger and see if we can get it to come up a bit faster. Not sure what the deal is here. My computer's thinking really hard, which is usually a good sign. When it creates the mini dump, it's actually creating a full view of the stack and everything like that. It takes quite a lot of time. It's been a long time since I've seen a Visual Studio crash. This would be an opportune time for that to happen. So, seems to work. Let me just take a quick look here and see what's going on. Oh, I forgot to actually invoke the Watson dialog. Sorry about that. And we'll pass in the message. So now if we try and delete the customer, you can see the UI is non-responsive and it's creating the crash. You know, having seen the crash dialog so many times, it's a wonder that it takes this long to come up. So basically what this dialog is saying is the app has crashed. This is not the Windows dialog that normally shows up. This is just our own thing that we've incorporated into the application. And if we actually go through the links here, we can see that the log file for my app is actually included in here. And if I wanted to, I'm not going to do it here for the sanity of my machine, I could actually open up the mini dump in the Visual Studio debugger now and go to the exact line where the app failed. So it's asking me what I want to do. Sure. If we opened it in the same VS session that we currently had open because all the symbols were available, we'd actually go to the exact line that threw the exception. Pretty cool stuff? Yes? All right. So I've seen this dialog so many times that I was kind of a little uneasy about showing how you could incorporate it into your application for fear that I may see it more times, but sure, we'll send it later. Okay, so what I'd like to do now is take a sort of change gears a little bit and jump into my.settings. And one of the things behind my.settings is this, that it is so incredibly easy to use, and it's such a vast improvement over the manual parsing and casting that's involved in config files in 2003, that as it is, even with no extensibility points, I think it provides significant value. That said, there are a lot of scenarios where the out-of-the-box behavior just isn't enough. The typical example would be that maybe you have a Visual Basic 6 app that you've migrated forward, and it has some dependency on the registry for settings, and you want to keep all those settings that the users have made over time. maybe you just use the registry as a general store for some settings because other applications rely on that location as well. So there are lots of reasons. Maybe you want to use a web service so that your websites and your rich clients both share the same settings store. All this is provided via the settings provider infrastructure. Just out of curiosity, did anyone see Stefan's talk that was a deep dive on providers? No one. Okay, great. No one will know if I say something wrong there. So the basic idea behind the provider model is just that there's a service that's being served up, and it's provided in a sort of general sense. So in the case of settings, all we do is we provide an implementation of get settings and set settings. And a custom implementation of a settings provider can implement those however they want. And we'll go into detail on that. Another question that comes up quite often in news groups is, I have an assembly, a DLL, maybe it's my middle tier, and it has a web service URL or a connection string. And I really want to be able to consume that from my executable. How do I share this setting between the DLL and from the exe? The most common case is, oftentimes I'll write a middle tier that has a web service URL and has a default value for that. But if there's an exe calling it, maybe it's like a help link or something like that, I want the executable to have the ability to override that setting value in the DLL. So we'll do a demo of that. And then before we get into any of that, though, I kind of want to demystify the whole settings code generation, what's going on under the hood, so that you can really understand how to plug settings into Windows Forms apps more effectively, because it's a little tricky under the covers. So we'll switch back over to code. And you'll notice, if I run my application here, I'll have to remember not to click on the delete customer. That almost looked like an IDE crash, but it wasn't. It's coming back. There we go. OK, so we run the application, and I've just implemented a little tools options dialog here. It just allows users to go in and change a couple of properties. The font in this case, set equal to 14, and you can hit OK. Now, what I want to do is take that user options dialog and actually have it do something with the main form. So if we look at the settings that are currently in the project, you'll see that I have one for the font, the back color, and the fore color. And I'm going to stop the application because it seems to be making my machine go super slow. And what we're going to do is effectively data bind a number of properties on the main form to these settings. The interesting thing about how we data bind settings, though, in difference to standard data, is that we can use the ambient properties of controls so that if I set, for example, the font of a main form, then all the controls on that form, where appropriate, will just pick up that font value. So here are my settings. If I go into the main form, you'll see that there's a new property selection, 2005, for application settings. And we're going to pop open the property bindings here. And I'll set the font and the fore color. It's just showing me the available settings that I've already added. And the back color. Now, the interesting thing is that we don't do this sort of blindly. We try and find controls where an ambient setting makes sense and others where it doesn't. So if I run the application, oh, well, that'll be fun. I think I'll change that. Thanks. that color, and it seems like it forgot some of the others. Not sure what the deal with that was. There we go. So what happens and what you're seeing in the background as I change these settings is Windows Forms is actually resizing the controls in the form based on the font setting that I have, right? That's a common problem you run into where you change the size of the text on one control and all of a sudden it's clipped and it looks really silly, right? So what we do is when you change this, when you bind this setting, we're taking the default value of the setting and scaling the UI to fit that. You can change that behavior if you want, but this is the default. So we've just gone ahead and bound a few things. If you notice, the tool strip didn't get those ambient properties. And that's actually an explicit decision because the tool strip has this nice gradient, and we only want to inherit things sort of explicitly. So I can go in here and add the property in manually for the font, for example. So now, when I run the application, I can go to Tools Options and say set the background color. Sure, peach looks nice. Then you'll see that it automatically gets updated. So all this logic that you'd normally have to write yourself just sort of happens under the hood because we use two-way data binding for it. But I want to actually take a look and show you the generated code so that you have a little bit better understanding of how this is all tied up. Because you may want to do the same thing for non-visual controls, for example. Maybe when a web service URL changes, you want to go ahead and grab the new data. And listening to the property changed event will allow you to do that. So if we crack open show all files, we can look behind the main form. And somewhere in this mess is the data binding for settings. So let's just search for. So basically, all that we're doing here is adding a simple data binding for this control. In this case, it's the menu strip. And we just say bind the font property of the menu strip to the font setting, which is defined in my.settings, and listen for the property change event. So we don't really have to write any code for that. So if we switch back to the settings logic here, one of the things that's kind of mysterious is how my.settings actually appears. Because anytime I add a new setting here, we're generating code in the background, right? So if I go in and type inside my main form here, my.settings somewhere, my new setting is automatically added. The way that we do that is within the designer, we're actually generating a partial class behind the scenes. So if we look at that class, you'll see that each property is really, you can't quite see it, everything on the screen here, is really just a simple wrapper for the application settings base class. So all this code generation is just doing the heavy lifting for you, right? It's just saying, go get this font value and cast it to a font object, because you probably didn't want it as a string value, which is what it's actually coming in. So there's really nothing special going on behind the scenes for my.settings. The interesting thing, though, is that in VB, we're actually automatically saving the settings for you. One of the things you may notice, if I go run this application again, it's going to remember exactly what the font color I had before was. I didn't write any code to do that. It just sort of worked. How that works is by hooking the shutdown event. Here's the add handler call. And basically, when we receive the shutdown event in this generated code, we're just calling save, right? And then save calls up to the settings provider that we're using, in this case, which is working over the config file, and it's serializing the values that I've changed out into an XML file. So there's really, my.settings as it stands is really pretty straightforward. But I do want to spend some time actually going in and implementing a settings provider now, as well as, sorry, I had a cough moment, as well as actually sharing these settings across assemblies. So let me pop open the Solution Explorer. So as you can see, I have my data layer here. And the main form is displaying some data from this data layer. The data layer is just going against a Yukon database, and I iterate through it, very bare bones stuff, right? Well, this data layer project, though, is a DLL, and DLLs can't have config files. That we put one here is actually a bug. There are a bunch of reasons why we can't take it out, but it doesn't actually do anything at runtime. If you put a config file next to a DLL, unless it's a VSTO, a Tools for Office project, it has absolutely zero effect. So what we want to do, though, is have the same sort of mechanism that the config file provides for the DLL, but we want to push that up to the exe. Then as the exe, I can then override the setting value in the DLL. So if we pop open the data layer here, you'll see that it has this one setting for the connection string. We won't get into whether or not having a setting as a connection string is a good idea or not, but I do want to now see that the value is defined in here. The value that's in this text box is actually the default value. It's what's burned into code. If we were to look at the designer-generated code, it actually is hard-coded to say, if I can't find a config file, use this value. And then in the exe, I've gone ahead and added the same setting, right? Same value here. And what I want to do is make sure that the DLL, whenever it's doing database lookups, and this executable is used, I want to make sure that it's using the value that's defined in the exe. So what I can do is jump back over and use some of the extensibility points within my.settings. Basically, we expose a number of events here if you want to listen for settings being loaded, settings being saved. And we put this magic attribute on the class, which basically says, whenever you're looking for settings on this class, first check to see if there's a settings class with this name in the calling exe. That's a lot to say in one sentence, but I think the code is a little more self-explanatory. So there's this settings group name, and the group name is basically a global identifier. And I've already defined the group name on the exe, so I'm just going to use basically the fully qualified name of the settings class in the executable. PDC 05. So now what's going to happen is whenever this class is asked for a setting, in other words, the data set is going to be asking my.settings, give me the value for the connection string. The settings infrastructure is then going to ask the exe for this value. Okay. So now, we run the application, make sure everything's still working okay. Data's still there. Now just to kind of prove that this is working, what we'll do is go into here and just set this equal to some bogus value. And if this isn't working, probably because I haven't typed it properly, then the database is going to fail, right? It's going to try to connect to foo, and it's not going to find anything. It's not looking good. I must have typed something wrong. Oh, it is actually working okay. So if that wasn't working properly, then the data layer would be trying to connect to foo. There's no such connection string as foo. And then it would have failed. So if we go in and then remove that attribute, you'll see that it's going to conk out. So now in our data set, we're failing because we can't connect to foo. So the bottom line here is just that a lot of times you have multi-tiered apps, and it looks like my.settings is really project specific. But in fact, by using some of these customization features, you can actually share those settings across multiple assemblies. It's probably the #1 question that we receive on the forums. So we'll go ahead and add that back so everything works okay. And what I want to do now is basically take what I've got and use the registry to persist some of these settings. Because right now, if we look at the executable settings, you'll see that they're all user scoped. And what that means is that if I go to my user directory, somewhere in here, there's this version folder that contains my own preferences. And every user who runs the application will have this user config file. But what I really want to do is, instead of storing this in a config file, I want to store it in the registry. So I'm going to go ahead and add a new project. Again, I've already written it to save you the agony of watching me type. And if we take a look at this class, it's pretty self-explanatory. We're inheriting from the settings provider class. This is something that's defined in the system configuration namespace, new for Whidbey. And it's what my.settings is actually using to serialize and deserialize the settings. So we provide the application name in case there are multiple people using the same provider. And then basically under the hood here, all we have to implement is how the values should be retrieved and set back into the registry. So this is just some kind of monotonous goo that we have to write that iterates over all the properties in my.settings. And then if you look down here, we're just writing it into the registry. Pretty straightforward. We'll go ahead and build that. And we just need to reference that settings provider from our executable project. And now we can go ahead and select a given setting. And you'll notice in the property grid, there's a provider field in here. And I'll drag it out so you can kind of, it's not so behind the scenes. And we just put in the fully qualified type name here. And we'll see if that builds. Everything seems to work okay. Now when we run the application, we're actually going to the registry. And you'll notice that because we're using a new provider now, that old hideous-looking peach color background, which is serialized into user config, is no longer being honored because there's no new value in the registry at this point. So if we would have to go in and change this if we wanted to update that. So we could change it to orange instead. And then it would be updated. So that's kind of the quick dive into my.settings. I do want to spend a fair amount of time on extending my, but I encourage you to stop by during the track lounge or anything like that afterwards if you have any more questions on this. It's kind of a huge space. We've only really touched the tip of the iceberg. And I think you'll find it pretty useful. So what I want to do next is show you real quickly how you can extend my.user. And I actually, inside my main module, if we jump back to that, you'll see that I was previously setting my.user explicitly. So my.user is basically, you can think of it almost as an alias for system.threading.thread.current principal. Say that a few times fast. And what we were doing previously was wiring up the currently logged on Windows user when the application started. Inside the application framework, we do that for you automatically, so it's no longer necessary. But sometimes it is necessary to use some alternative store for users, right? Maybe you have an ASP website that uses the new personalization features, and you want to leverage that directly. You can always do that with my.user. You just need to provide your own principal. So a principal and an identity are basically just the two interfaces in the .NET framework that encapsulate authorization and authentication. I've already cooked some up. Sort of implementing them is a little bit outside the scope of this talk, but I will show you how they can be tied into my.user. So here's my little user manager class. I just have I'm actually using the ASP databases behind the scenes. So if we open up the data set, you'll see that this is really the ASP stuff that gets installed whenever you use personalization. And we're going to leverage that directly from our Windows Forms application. So we'll add a reference to that project. And now, if we go into our little login form here, all we need to do is basically set my.user equal to this new principal. It's called SQL principal and SQL identity. And basically, these are just thin wrappers atop that data set that go look up and check passwords against the database. So here's the code for that. Basically, all we're doing is setting the current principal on my equal to this new principal. Then all we have to do is go ahead and flip the switch that tells the application model, don't tie in the Windows credentials, allow the user to specify them. So now when we F5, we get a username and password dialog box. And that's basically it. And if you see at the title screen here, the name has changed. It used to be my Redmond account, or it was an administrator, I think. Now it's using the username that's defined in the database. So it's really that simple. If you have a principal implementation, or you're willing to spend a few minutes kind of reading about it, plugging that into my.user is really pretty straightforward. So the last part that I want to talk about is actually adding new parts or new properties to my itself. And there are a lot of reasons to do this. And I think that, you know, when we first came out with saying that the my namespace is extensible, a lot of people just sort of gratuitously started adding things. It was my.this and my.that, and it didn't always make sense within the my namespace. So before jumping into code and sort of showing you the guts of it, I really want to just spend a few minutes talking about why you should do it and when you should do it and when to avoid it. My slide got a little messed up. I don't know why that happened, but the first line actually says employ stateless APIs when appropriate. The thing that we try to do within my, and really the thrust behind my, is that many application models out there, whether they be in the framework or elsewhere, provide a functionality that you need. That's not the question. The problem often is that there's some abstract factory you need to call, some, you know, arcane interface you need to implement just to get some simple functionality working. And oftentimes it's frankly not necessary. So what we try and do with my is really structure things as task-based and stateless, meaning that you see an API, it solves the problem you want, and you don't need to know anything or have called any other APIs in order for that method call to work. So when thinking through extensions, think of things that basically require no state whatsoever. Those fit extremely well within my. If you look at I think the best example of stateless APIs is the file system class. I don't know, has anyone played with the file system class at all? A little bit? It's probably one of the most pragmatically designed classes, I think, within the My Namespace, specifically because the methods are named appropriately, copy file, and you just give us the two file names. There's no objects to create or anything like that. Definitely probably the underwriting design point of My. If you do have to provide state, though, make sure that that state is global to the application. Things like my.application.log, my.settings, these aren't instances that we serve up sort of on a temporary basis. They live for the lifetime of the application. Because you can expect users to call the API with the expectation that it'll always be there, right? You call my.settings, you didn't expect that you had to instantiate something first. You just expected that it'll still have the same setting values that had the last time you called. And sort of related to the first two bullet points is that some APIs will require some type that you've never seen, right? It may be exactly the thing you're looking for, but it'll take you 2 hours of reading through documentation to figure out how to call it properly. Avoid that whenever possible. Strings, integers, dates, things like that make great parameter types for My. If it's a complex type, it usually doesn't work particularly well. And sometimes you will have these sort of temporary instances. A great example is a file, right? It's pretty unlikely that a file is going to be open for the entire lifetime of your application. But you may want to provide some shortcut method to open a file or open a database connection. In that case, use a factory method rather than providing some deep hierarchical object model. And the thrust behind a factory method is just that there's some open method, right? I call open text file, and it gives me back a file object. And that applies pretty universally across the My Namespace, at least with what's in the box. Most of the things that we provide that are sort of temporary like that use that pattern. And the last piece, I'll talk a little bit more when we get into the demo, but keep in mind that My is shared across the application, and you can't always assume that even though these are instances, that users will be always calling them from the same thread, right? So, for example, if you have two threads and they both call my.application.mainForm, right? Well, you want to make sure that there's not going to be a collision there, because chances are good that the user is going to have no ability to really synchronize those two calls. They don't own my.application, and they won't own your extension. So make sure when you write your extensions that they are thread safe, that they can handle concurrent callers. And we provide a construct to do this. It's really just one line of code, but something to keep in mind. Sort of lastly and most importantly, it's just to keep the .NET Framework guidelines in place. The folks over on the framework team have really been working very hard to incorporate a lot of what we do in My into the framework. And I think that it's really improved the guidelines overall, and they're much more down to earth now, and really do a good job of providing sound guidance for sort of the massive class library developers out there. So before talking my head off here, I just want to spend a few minutes actually going through a few simple scenarios of extending the My Namespace. If I don't touch on something that you're really interested in, absolutely stop by the track lounge. I will try not to give you the flu, but we'll have plenty of time afterwards as well. So, and as we go through these, kind of keep in mind that main diagram that we showed in the beginning, which just kind of really underscores that all these My Namespace extensions that we're adding are actually added to the current project. We're not referencing any new assemblies here. Okay, so I'm just going to add a new module here, and thank you. I can see it just fine. So I just added a new module, and I have a bunch of snippets for these just to kind of speed things up a little bit. And the first thing that people ask is, how do I just add a new property? And what do I need to know about that? So if I switch to full screen, you'll see that inside here, we have the namespace my, which is key, right? The module itself needs to live in the my namespace if you want the property to show up when you type my dot. The next is this attribute called hide module name. It's something that we had to put into the framework this time around so that when you type my dot, you don't see the my extension module module itself, right? You just want to see my dot new property. And the rest, I'll just go ahead and add, I don't know, my favorite color, number. And I'm going to talk about the thread-safe object provider in a second. And that's basically it, right? So here's our property. It's just a simple property inside a module. Now that bit that I was talking about, thread-safe objects, is, under normal circumstances, very hard to obtain, right? If you're writing in class library, it's a lot of work to go through and synchronize all those method calls so that you can have concurrent callers. What we do in my is something considerably different. We have this class called the thread-safe object provider, and it's basically a factory class. What it does is you tell us what type you want to serve up in my. It's a generic class, and then you just call getInstance on it. And what we do is whenever somebody accesses this property, we do a lookup, and basically you can think of it as a hash table. And if there's already an instance of this class kicking around, we'll return that. And if the person's calling from a new thread, then we'll fire up a new instance. So you actually, in developing these my extensions, you really don't need to worry about any sort of synchronization as long as you use this class. Okay? So the next part would be to extend my.computer. My.computer is actually a partial class that's defined within the current project. So what I've done here is just add a simple send mail method to my.computer. And the only things worth mentioning here are, again, it's in the namespace my. I've declared this as partial friend, not because you necessarily need to, but just to let you know that all these partial classes that we defined are defined as partial friend. In VB, this is totally optional, because friend is the default and partial isn't necessary. Everything will still compile just fine, but something to keep in mind. So if we were now to use my.computer, you'll see that there's my new method sendMail. Just shows up. It gets all folded in via the partial class goo that we have behind the scenes. And if you also saw there, I wouldn't do it because it'd be a recursive call, but here's my new favorite number, my.favorite number, which just shows up. Again, the my namespace, just defining your project, you add new properties to it, they just show up. And the last piece, and I think this is probably one of the areas where people will find themselves extending things, adding extensions most readily, is within the application events file. So if we jump back here, we had this idle event before, right? Which we were wiring up individually. But really what I'd like to do is instead have the idle event exposed off of my.application directly. That way I can handle it anywhere and everything will get marshaled back properly. So I'm going to delete this line and delete the lines on initialize. And now I can do basically the same thing that I did before, but actually add the event to my application directly. And what we've got here is, again, namespace my, partial friend class, my application. We're overriding the onInitialize method, hooking up the event. I've already declared it here, so I need to fix that. And then we just declare the event as public, and then anybody who's consuming my application can handle this event. So I'm going to see if I can find. Just get rid of that. And now, as I'm in here, while I'm handling events, you'll see that the idle event is available, and I can just handle it here. And it appears just as any other event within my would appear. So the last part, and we are certainly running out of time, but the last piece that I want to kind of talk about a little bit is how to get these my extensions actually out to other people, right? Because chances are good if you know how to write the my extension, you may not necessarily need the my extension, right? A lot of times what I like to do is maybe I'll find some slick way of doing something or some common coding pattern, and I'll incorporate that into my, so that other developers don't have to go through the agony of figuring out how to do it, right? That's kind of the idea. And the problem with that is, though, that when you create a my extension, you're adding something to the current project, right? You're not just adding a new namespace to a class library. So you actually need to have some mechanism for deploying the my extension and getting it into the other user's project. By the same token, you also need to differentiate, the actual guts of the extension that you're providing. Let's say that Watson crash dump utility, right? Well, that's a few thousand lines of code. I'm not going to dump that into every user's project who uses it. So I want to divorce the extension logic from the actual heavy lifting that the extension provides. And the way we've found is most effective to do that is to actually use a Visual Studio item template. And prior to 2005, this would have been asking you to step outside and put a fork in your eye. But in 2005, the template infrastructure is significantly better, and it's actually very easy to do. We could go ahead and you'll notice that there's actually an export template utility within Visual Studio. You can just select a file and say, create a template out of this, which is what I did here. And what you basically do with the my extensions is you put the code that needs to be in the user's project in an item template, and then the assembly itself is deployed with what's called a Visual Studio installer. Has anyone heard of VSI before? It's new for Would-Be. It's very cool. I'll show you a quick demo of it in a second. But then the user experience is basically that the my extension, I just went to add new item. And down at the bottom here are all the things that I've added. So I added my little user options template here. And here's a little extension to my that adds some hardware events. So just click on that, and it adds all the events for me. It also added the reference that I need to my DLL that's actually listening to these window events under the hood. And that's it. As a user, this code, effectively, I didn't even need to include this code if I wanted. If I really want to minimize sort of the extent to which the my extension code is copied to all these projects, I could simply add the reference when you add the template. That would be sufficient as well. But now all the user has to deal with is what they want to do in these events. I added 4 events, and all they have to worry about is what do I want to put in the event handling code. They don't need to worry about assembly references or anything like that. And the my extension as a template actually has another fringe benefit, which I think is particularly important. And that is that there's the potential that when you add something to your project, especially a my extension, that it may already exist, right? You may already have added sendmail, for example. So in which case, when you add that, you're going to get a compilation error. It's going to say this method is defined twice. So by using a Visual Studio template, you have 2 options. When you create the template, you can either rename the method when it's added. Visual Studio will go in and look to see if that method already exists and then rename it. Or you could simply do nothing. You could make the template basically not add the method at all, not add the extension, because it's already been added and there would have been a collision. So that's one concern we definitely heard from early on, is just that, well, if I start adding all these my extensions, how are you going to mitigate the risk where when you add something in the box, there's going to be a collision? And this is one of the ways, by deploying via template, that you can really mitigate some of those problems. The other thing to keep in mind, and I sort of pointed this out earlier, but I just want to underscore, is that the extensions themselves are really the entry point into the value that you're providing, right? The class library itself is not automatically imported into the project. So you won't have to worry about namespace collisions in the class library, just in the My extension itself. Does that make sense? So one of the things, just as a quick demo, the developer who wrote this and who's responsible for it is actually here at PDC. If you're interested in this technology, there's actually a hands-on lab on it. But to give you an idea of what the experience, if you were to deploy a My extension to the web, for example, you would just double-click on this VSI thing. And in this case, it's a starter kit. And basically, you can view what's inside of it. So this gives the user an opportunity to go in and interrogate what your My extension is and figure out whether or not they want to install it or not. It'll also install the references you need, et cetera. So Visual Studio admittedly includes a hierarchy of folders that is known to about 4 people on the planet. It's very complex. And the VSI infrastructure really simplifies that by user double clicks on it, the file just goes in the right place, and the next time I fire up Visual Studio, the template will be there. So this technology is a little outside the scope of this talk, but certainly see me afterwards or stop by the hands-on lab if this is something you're interested in. So we've more than exhausted our time, but there's no one in here afterwards. I checked that first. So if you have any questions, I encourage you to just come up afterwards, or I was planning on heading down to the track lounge for a good hour and a half or so, and I'd love to talk with you. I'd love to hear how you feel about this stuff and if there's extensions that you're interested in developing, et cetera. And I'll stick my email address up here so that you can, I guess you can't see that too well. I'll highlight it or something. It's jbinder@microsoft.com. But I'll have the demos. The demos are actually in a hands-on lab. If you want to go by and stop by for that, I can also give you the files individually. I can just give them to you on a USB key. Some of them are on the CD, and we also have a resource CD at our track lounge that has them on it.